All right, today we're going to pop the hood on Formula One and really dig into the mind-bending science that turns these machines into rockets on wheels. You know, this isn't just about speed, it's about pushing the absolute limits of physics and human endurance. So let's dive right in.
And really, there's no better way to set the stage than with this. I mean, when an astrophysicist, a guy who literally lands rovers on Mars, calls Formula One the pinnacle of innovation, you know we're talking about something truly special. This is way more than a sport. It's a showcase of human ingenuity taken to its absolute extreme.
Because what you see happening out there on the track, yeah, it's so much more than just a race. It's this high-speed ballet of aerospace engineering, cutting-edge material science, and just pure, raw human grit.
And this really frames it perfectly. We're not just looking at four wheels and an engine here. This thing is a mobile laboratory. Every single component, from the wings to the chassis, represents thousands and thousands of hours of research across a bunch of different scientific fields.
But, the machine is only half the story. The physical demands on the driver are absolutely staggering, and it all starts with this invisible, crushing force we call G's.
5 Gs. Let that sink in for a second. That is the incredible amount of lateral, that sideways force, a driver has to endure through a single high-speed corner. I mean, just try to imagine 5 times your own body weight trying to rip you out the side of the car.
And to put that into perspective for you, NASA actually throttles its rockets to make sure the G-force on astronauts stays below 3G. And remember, that's pushing them straight back into their comfy seats. F1 drivers are handling almost double that, pulling them sideways, corner after grueling corner. It's just insane.
So what does that actually do to a person's body? Well, drivers describe their heart feeling like it's literally dangling inside their chest. Their organs are shifting around, their head, which now feels like it weighs 50 pounds, is just trying to tear itself off their neck. Those super tight restraints and custom seats, they're not for comfort, they are purely for survival.
So, the big question is, how do these cars and the drivers inside them even stay on the road under those kinds of forces? Well, the answer is in the car's design, and it comes down to one key aerodynamic principle that basically turns physics into a weapon.
And that principle is called downforce. Think of it like an invisible hand just slamming the car onto the track. At speed, an F1 car can generate over 2 times its own weight in downforce. I mean, theoretically, that's enough grip to drive upside down on the ceiling of a tunnel. Without it, the car would just fly right off the road.
This slide shows you exactly how it works. You know how an airplane wing creates lift by making low pressure above it? Well, an F1 car's wings are just flipped upside down. They do the exact opposite. They create high pressure on top and super low pressure underneath, and that difference in pressure literally sucks the car onto the asphalt.
And just how powerful is this suction? Well, at the Las Vegas Grand Prix, a car generated so much downforce that it literally ripped a heavy metal drain cover right off the street. That is the raw, unbelievable power of F1 aerodynamics.
But, the race isn't just won out on the track. Some of the most critical make-or-break moments happen off of it, in the pit lane and even in the digital world, where every single fraction of a second is everything.
2.1 seconds. That's it. That's how fast a top-tier pit crew can change all 4 tires on a car. It is an absolutely breathtaking display of human choreography and precision. Just blink and you miss it.
And that incredible speed is no accident. Before a race, you'll see the pit crew warming up, just like athletes. They're stretching, doing calisthenics. They have to be in perfect physical and mental sync to pull off a stop that fast.
But there's this other kind of hidden danger. In a car with hundreds of thousands of parts, all sourced from suppliers across the globe, a single faulty, or worse, hacked component could be lethal. Imagine a bolt that's been designed to fail at over 200 miles per hour. This is the new, unseen frontier of racing security. So, to fight this, teams worked with cybersecurity experts. They get these indicators of compromise. It's basically threat intelligence that helps them lock down their own systems and their entire network of suppliers. Because in F1, a digital attack isn't just about stealing secrets for a competitive edge, it's about protecting that driver from a catastrophic failure.
And all this kind of brings us to the core philosophy of F1 engineering. The sport is defined by these incredibly strict, detailed rules. But here's the crazy part. Instead of limiting innovation, those rules actually fuel it.
Just take sustainability, for example.
F1 is pioneering a completely carbon-neutral fuel. They're using renewable energy to split water, capturing CO2 right out of the air, and then they combine them to create synthetic gasoline. It allows them to innovate for a greener future without having to completely scrap their engines. It's genius.
And this quote, this just reveals the entire mindset of an F1 engineer. They don't hate constraints, they love them, they thrive on them. The rules themselves become the target. The whole challenge is to build a machine that exists perfectly, right on the absolute edge of what's allowed.
And this just captures that spirit perfectly, doesn't it? The goal in F1 isn't to be comfortable. It's to push the car right to the ragged edge of what's possible. Races are won in that razor-thin margin between total control and total chaos.
It's this relentless, unending hunt for the next fraction of a second. So that leaves us with one last thought to chew on. In a sport that constantly redefines what's impossible, what limit is going to be broken next?